Now, let's think about traversing the list. Here, traversing the list is basically similar to scanning the array. So really want to scan each element, each node in the list. Okay. So for in this code, we have for add front 10, and then add front 20, and then add front 30. Okay, that means what? We have add front 10, and then add front 20, and then add front 30, right? And pointer now points to the first node. So that's what's going on. Okay. So how do you traverse? In array, you have what? Some index variable I, and then I starts with the 0. Next iteration, you make sure the I is 1, and next time I is 2. So you keep incrementing the index. Well, in the context of a list, we don't have that index, and it doesn't make any sense. Instead, we actually have something similar to I as a pointer. Okay, so we're going to have some pointer variable. Let's say t. Okay, at first it'll point to the first node, and then what? Next time it'll point to the next node, right? And the next time it'll point to last node. And then you got to know when to stop, something like that. Does it make sense? So as we learned before, how do you make sure first time it points to have the, what is it? Pointer variable 2 points to the first node. So at least we should initialize like this. Remember, as we saw, the previous video, when you copying the pointers, okay, the arrow destination really what matters. So here, what we want is have the pointer t to point to the 30, the node containing 30. So what kind of pointer does that have information? Well, L points to that node. Okay. So what does that mean? That means initially we should have t pointer t, okay, and then make sure it points to the first node. Okay, so that's the initial condition, right? And then we're going to do kind of loop because the number of nodes will be so many. Right? There should be many nodes, and then we're going to just keep doing it again and again, multiple times. That's exactly the concept of loop. So how do you do that? So make sure you want to point to the next node, right? What does that mean? We want to point, have the t point to this node. Okay, question is, well, which arrow does that have the, destination? This one, right? And how do you access that node? That's really what? L arrow and next, right? So what does that mean? To move to the next node, you got to do what? L arrow next, or you can actually use T arrow next. And next time, if you have T pointing to this, to access that node, you're going to do what? T, we update it to be T arrow next. Does it make sense? So that's what it is. So keep doing this T arrow next. And then when do you stop this loop? Well, when T is empty list. T is really containing null, then that means what? There's no arrow, right? There's no destination. You're stuck, dead end, time to stop. Make sense? So the code should be like this. So you keep doing it. What's the condition? Keep doing it. Condition is what? Keep doing it when he is not null. If he is null, you gotta stop. Well, there's no nothing to point to. So what does that mean? So here, if while t is not null, we keep doing it. So what do you do? So here we're traversing each node. We're traversing the load, like we're basically visiting all the nodes. So let's make sure. Let's just print. Okay? Print out the data. Okay. We have to put that slash. So here, what do? You print out the data. Oh yeah. And then what? For the date. Okay. You gotta make sure t points to the next node. So that means what? T equals arrow next. Okay, that's how you traverse the list. It's simple enough. So let's have this. And what? You gotta what? If the code is correct, you have to print out 30, 20, and 10. And that's the case. Okay. So that's how you print out. So remember, you can actually change the what? While loop into for loop. So this is initial condition, initial, and then this is where's a looping condition. This is update. So that means what? If you change that into a for loop, this is goes here, and then this will be what's in the second. And then update will be last, right? This for loop. And it looks neat. So basically, so whenever you want to scan the list, you gotta use this template. Start p to be initialized with L, and then you keep doing it while he's not null. And then for the next update, t is basically what's TL next. Then inside the for loop, you basically access the data for that. Okay, that's what it is. And if you compile that again, it's the same. Okay. So then what? How do you compute the length? Well, if you access each node, it's easy. Right? Initialize the counter to be 0. And then instead of doing this, implement counter. And then this. This. Okay. And then we are expecting what? Okay. So that's how you compute the length. Okay. Now you are actually scanning all the nodes. So far we kind of ignore the issue of memory leak. We used a bunch of catalogs and then we just didn't really care. Okay, so let's try to remove it. Yeah, we'll remove. So let's try to clean up the list. Okay. How do you clean up? Well, again, you should have t variable, right? And then what? When t is in here, you remove it. And then make sure t points to the next node. There's a problem. What's the problem? Or like some care is necessary. What do I mean? If you do that first, removing that first, there's two operations. So removing the node and then moving, the what is it? Update the pointer t so that it points to the next node. Okay. There's a little bit of problem. If you remove the node first, then the problem is this guy, okay, has the information of this destination for the next arrow. But because this is removed, this thing is removed, that arrow information will be lost. Okay, so what does that mean? That means this should be not the first. What should be first? This should be first. Okay, and then if you update the T safely, remove that node. Okay, so that's a little bit tricky part, but other than that, it's basically the same. Okay, so that means what you need to have some backup pointers. Okay. Okay, so here, let's do that. Okay. So again, we should have initially. Okay, what we do is basically doing it. Next. Remember that operation has to be done. But before doing that, we're gonna have backup pointer. Why do you need a backup pointer? Old. So now if you have backup pointer old, you have backup pointer old, and then it points to what T points to. What's the benefit? Benefit is now T is not pointing to this one, but pointing to the next one because that's what T next done. Now you are sure that T is moved on, but now you can safely delete that old node using the old pointer. Okay, so that's the beauty. So now we moved on, and still you can free the old. Okay. So that's clean up. Okay, so now we clean the file. Okay, there's no push happening.